y is equal to 5x plus 7, and this is like one of the lines. And another line, it could also be y is equal to 2x plus 3. So to find the intersection point between the x and y, we'd have to be able to find out what values of x and y work so that both of these equations can be satisfied correctly, right? Because, for example, if we do, like, let's say random numbers like x and y are equal to, let's say we say x is equal to 2 for this equation, then we'd have 5 times 2 plus 7, which is equal to 17. And then we could say, okay, well, this satisfies y is equal to 17. And what this would mean is that this equation works, this equation works when x is equal to 2 and y is equal to 17. However, if we try to plug it into the second equation, if we sub in y and x for these values, at 17 is equal to 2 times 2 plus 3, we very quickly see that this doesn't work because we get 7 instead of 17, and this is not true. So we need to be able to find out values of x and y that work for both of these equations. So this is really easy, right? Because all we have to do is now set them equal to each other. Since these are both equal to y, we can now just say, well, we can just say that 5x plus 7, which is from here, is equal to 2x plus 3, which is from here. And now we solve to find a value of x that satisfies, or that works in this case. Well, we can subtract 7 from both sides, because what you must do to one side, you have to the other. That leaves us with 5x is equal to 2x. Oh, this should be a 7, sorry. 7. 2x minus 4, because 3 minus 7 is minus 4. And then we can subtract 2x from both sides. So I can remove it from here. This leaves me 3x is equal to negative 4. And if we divide 3 by both sides, we get x is equal to negative 4 over 3. So now we know that x works, the value of x for negative 4 over 3 works for both of them. Great. So I'm going to sub x back into any of the equations. That really doesn't matter. I'll sub it into this one. I'll get y is equal to 2 times negative 4 over 3 plus 3. This equals negative 8 over 3 plus 3. I can do negative 8 over 3 plus 9 over 3. And this gives me 1 over 3. So the system of equations works for when x is equal to negative 4 over 3 and when y is equal to 1 over 3. We can just double check with the first equation as well, 5x plus 7. What we could do is we can say y is equal to 5x plus 7. Then we can say, well, y is equal to 1 over 3 equals 5x, which is negative 4 over 3 plus 7. And if these equations work out, they're equivalent, then we know that we found the intersection point because this value of x and y exists on both linear lines. Then we say 1 over 3 is equal to negative 20 over 3 plus 7. 1 over 3 is equal to negative 20 over 3 plus 21 over 3, since 7 is equal to 20 over 3. Then at this point, we can say that 1 over 3, we can see, well, what's negative 20 plus 21? It's just 1 over 3. We see this works, and we see the point of intersection will work at where x is equal to negative 4 over 3 and y is equal to 1 over 3. So, yeah, hope that helped, and thank you so much.